Hello everyone, my name is Masma Sultan. Today what I am going to do is to present a topic based on geotechnical trade. I hope you will listen to it fully. So I have chosen a topic on ground improvement techniques. And what is in the topic? What I am going to discuss is the introduction and some various ground improvement techniques which helps us to take the major steps and all. So I hope you will get to listen this. I have chosen various references for this. I hope you like it. So let us start now. The topic is ground improvement techniques. So first of all, the introduction. As you can see, the groundwater is usually considered as one of the most difficult problems today that has to be handled in any civil engineering construction. The impact in construction project is enormous. It affects the design of structure, construction procedures and overall project cost. The current trends of population growth have increased the land values, creating demand for development of sites which were previously considered unsuitable. Often, groundwater is a problem that must be solved. The purpose of dewatering is to control the surface and subsurface hydrologic environment to permit the structure to be constructed in dry. Now, what dewatering means, the separation of water from the soil, or perhaps taking the water out of particular construction problem completely. What this leads to is the concepts like pre-drainage of soil, control of groundwater, and even the improvement of physical properties in soil. Now, talking about dewatering, the functions are to provide a dry working area for construction, to reduce the lateral pressures on foundations or on retaining structures, for example, retaining wall and etc., to reduce compressibility of granular soils, to increase bearing capacity of foundations, to prevent liquefaction due to upward gradients, to prevent surface erosion, to prevent or reduce damage due to frost heave. Now, what are the methods of dewatering is the shallow excavations. And the shallow excavations, what comes in this excavations is pits and ditches. That is some pits or interceptor ditches. The second point is intermediate excavations. The intermediate excavations well points, vacuum dewatering, electroosmosis, and deep excavations, which is jet or venturi pumps. Now coming to the topic, latest ground improvement techniques. The techniques, we can say there are various ones, but the most important one, vibrocompaction method, vacuum consolidation of soil, preloading method, thermal stabilization of soil, ground freezing technique, vibro replacement stone, mechanically nailing technique, micropiles, general grouting techniques, in which jet grouting also came. So these are the various techniques. These are the recent methods of ground improvement techniques used for the stabilization of the soil. The vibrocompaction, sometimes referred to as vibroflotation, it is the rearrangement of soil particles into a denser configuration by the use of depth vibration, powerful depth vibration. It is a ground improvement process for densifying loose sands to create stable foundation soils. The principle behind this is very simple. Now the advantages of vibrocompaction method in this is it reduces the foundation settlements. The reduction of foundation settlements is provided and the risk of liquefaction is reduced due to the seismic activity. It permits the construction on granular fills also. Now coming to the second point, vacuum consolidation of the soil for ground improvement. It is an effective means for improvement of saturated soft soils. The soil site is covered with an airtight membrane and vacuum, which is created underneath it by using the dual venture and vacuum pump. Vacuum assisted consolidation preloads the soil by reducing the pore pressure. The applications we can say is to replace standard preloading techniques. It eliminates the risk of failure. It combines with the water preloading in scarce fill area. This method is used to build large developments on thick compressible soil. We can say that. It combines with embankment preload using the increased stability. Now preloading. Preloading has been used for many years without change in the method. Preloading, it is the process of placing additional vertical stress on a compressible soil. It removes pore water over time. The pore water dissipation reduces the total volume, causing settlement. The surcharging, we can say, is an economical method for ground improvement. It is a process, it is a method, you can say. Surcharging is an economical method for the improvement of grounds. The soils treated in this are organic silt, warped silts, or clays, soft clay also. Thermal stabilization of soil for ground improvement. Heating breaks the soil particle down to form a crystalline product. It uses electric current to heat that soil and modify the characteristics of the soil, or we can say physical characteristics of the soil. Heating soils permanently alters the properties of the soil. Depending on the soil, temperatures can range between 300 and 1000 degrees Celsius. The impact and utility should be considered when heating is used in this. The applications we can say is the densification and the stabilization, immobilization of radioactive or contaminated soil also. Now coming to the ground freezing technique for ground improvement. It is the use of refrigeration to convert in situ pore water to ice, in simple words. The ice then acts as a cement or glue, we can say, bonding together to increase their combined strength and make them impervious. The ground freezing considerations are thermal analysis, refrigeration system, geometry, etc. etc. Vibro replacement stone columns for ground improvement. Vibro replacement extends the range of soils that can be improved by vibrating techniques to include cohesive soils. The reinforcement of the soil with granular columns is accomplished by the top feed method. The stone columns, the important stone columns are ground conditions, permeation, degree of saturation, etc. The principle we can say this of vibro replacement technique. In this, the stone columns and the soil form an integrated foundation that supports system having low compressibility. In cohesive soils, excess pore water pressure is readily dissipated by the stone columns. The reduced settlements occur at a faster rate. It is normally the case with cohesive soils. There are various types in this, but we don't have to go that far now. I will leave the topic here. These are the main techniques for the grounds, soils. I hope you will care to listen this very well. I really am not that good in making a YouTube video, but this is my first time and not the last time, It is the first time only. I hope you will like it. I hope you will subscribe and like this video. So yes, आज के लिए बस इतना ही. Thank you very much.